All right, we talked about sketching basic curves and shifting and what have you. The other important function is just polynomials in general. So some ideas when we have to sketch polynomials. The y-intercept is the constant. It's the same with anyone because obviously if you substitute in 0 into all the pronumerals, you're just left with the constant. So it doesn't matter what type of polynomial, a linear function, a quadratic, a cubic, it's always going to be the constant number. So let's use this one as an example. Now I don't have to expand the whole thing out to work out the constant because I know that when I do expand it out, it's always going to be the constant times the constant and so on. So this one's going to be 1 times negative 1 cubed times 2 squared, which gives me a value of, let's plot in our y-intercept of -4. Now, x-intercepts are obviously the solutions to the polynomial equaling 0. So that's why we like to factorise the polynomials. Now, all polynomials can be factorised down to a combination of linear functions and quadratics, which I think I've mentioned before. But this one's nicely factorised for us altogether. This is where the question gets a little bit harder now. We have to find the x-intercepts. That's the number that makes the parentheses equal to 0. So the first one would be -1. Very good. The next one? Positive 1. Very good. And the next one? -2. Very good. So there's our x-intercepts. Out of the extremities, so out of plus or minus infinity, the polynomial will always act like the leading term. And so that way you know where to start your curve and where you finish your curve. Whatever the leading term's doing, that's what your polynomial is going to do. So the leading term will be x times x cubed. Good, up to power 4. Times x squared. Now if I said to you draw x to the power of 6, you would draw, so like flatter at the base. So, but the key part is we know it starts up here, finishes up here. So that's what this polynomial is going to do. It's going to start up here and finish over there. Okay. Now, even powered roots will have a U shape. Basically, your x-intercepts behave like the power of the root. So even powered ones will turn like a parabola if it's squared and so on. Now, x plus 2 is squared. So I know here at -2, I'm going to get like a turning point. It's not going to cut through the axes. And because it starts up there, I know it must do something like that. It's going to come down and turn there. Odd powered ones, other than the power of 1, of course, because the power of 1, it cuts like a straight line. It just goes straight through. Will inflect like our cubic. Now we've got x minus 1 all cubed. So over there at +1, it will do a little inflection at 1, just like the cubic would do. And I'd say through -1, it'll just be a straight line. Voila! There's our curve. Is that not a beautiful thing? Now, how high up it goes, how far down it goes, this is just a rough sketch. Once we do a bit more work on calculus, we'll be able to locate the position of those turning points exactly. But for a rough guess, so we've got an idea of the shape of the curve, that's not a bad way to go. Okay. If you can factorise it completely to be a perfect whatever the power is, then we've basically got the basic curve, shifted a units left or right. If I wanted to solve this inequality then, I could do it like we did with quadratic inequalities, where I could think about it and say, hey, what we're really saying is, when is this graph below the x-axis? And that would solve the inequality. So if I was to draw x minus 1 squared, x plus 3. So what have we got? I know that the x-intercept there at 1, there'll be another one there at -3. Whoop. It turns at 1 like the parabola, just cuts through at 3. The leading term is x cubed, so I know it starts down here, finishes up there. There's the graph. We're saying, when is that graph less than or equal to 0? Now, common mistake is to forget about the point 1 because it just touches. But solution x equals 1 is possible because it's less than or equal to 0. And x equals 1 would make that equal to 0. So when is it below? There we go, those x values as well. So we get x is less than or equal to negative 3, or x is equal to positive 1 is our solution. 3B.